Now let's introduce the acquisition function of our machine. Now we are going to go into single channel acquisition and analysis. Analysis interface. Click F4 to select Customize. Acquisition parameters. There are time domain waveforms and total value trends. Two acquisition types. Then the signal type has acceleration respectively. Three types of speed displacement. Now let's choose a speed. You can also set the up and down line frequency. The lower limit frequency we generally set to 2 Hz. Upper frequency. Choose according to one speed of our machine. Generally choose 10 times the frequency of conversion. So now we have a 3000 RPM device. We can choose 500 Hz. Waveform length is generally selected by default. After setting these parameters, we can click Confirm to collect. If we need to collect a large number of this type of machine, we can also save properties. Afterwards, you can directly select the corresponding attribute for collection. Now let's click Confirm. This is the name of the measurement definition just now. It takes our waveform length for K-speed and time domain waveform. Up and down line frequency, date and time. To save as a default name. After we click Confirm, the page for collection and analysis appears. Start collecting now. Wait until the value stabilizes. We can click to stop collecting. It's now stable at about 0.15 millimeters per second. We click to stop collecting. Now we can save through F2. Or use other analysis methods according to F3. We save first. The save name is the same as before. Also single channel, 4K speed time domain waveform date time. A default name. We click Save. Then click Analyze Methods. There is a corresponding time domain, spectral and eigenvalue analysis. Inside the eigenvalue is the corresponding peak, peak-to-peak RMS maximum, minimum value and other values. Spectrum in analytical methods. It's the spectrogram we just tested. We through the keyboard. 1, 3 keys to zoom in and out. Adjust left and right through the up, down, left and right keys. Translate left and right with 4 and 6 keys. The red cursor now is a back frequency cursor. We can also choose F4 to switch the variable frequency cursor. Now it is the function of single channel acquisition, and then we come back. There is a two-channel acquisition analysis. This function requires us to connect to sensors. It needs to be in the second port of the sensor, also a vibration sensor. Then set the tracking channel to be consistent. I won't repeat the narrative here. We plug the vibration sensor red dot to red dot into port A. The speed sensor is also plugged into the speed interface with red dots to red dots. Now we do data collection. Speed acquisition first. Confirm whether the reflective sticker is attached to the position. Brightening sticker when passing. If this little light behind the sensor flashes, it proves that the reflective sticker is attached. There will also be values on the screen. You can stop the collection below, then return to the dynamic balance acquisition interface. Now let's create a new measurement definition. There is single-sided and dual-sided dynamic balance on the screen. Let's take one-sided dynamic balance as an example, and the rotational speed of the input simulation table is 3000. Indexing direction. It means, do I add the counterweight in the same direction as the speed or in the opposite direction? Generally, choose the counterweight method in the same direction, any position. It's 360 degrees where I can rotate. Counterweight can be added anywhere. If it is a fixed position, we based on the number of counterweight holes in our simulation table. To enter, our simulation table has 24 holes. Input 24, 0 point offset. It means whether the angle of my first hole is offset. Generally, our default is 0 offset. Here are some basic settings. In the advanced settings, we can choose the type of signal acquisition. Is through the displacement value, acceleration value or speed value to measure. If it is 3000 RPM, our general recommendation is measurement by speed RMS. Then the upper limit frequency is adjusted according to the speed of the device. You can do it within 10 times the frequency of the transfer. This is 3000 RPM. The transfer frequency is 50 Hz. We can set it within 500 Hz. Then the default value of the average point is OK. Now we can start. After that, enter the interface of node name entry. It uses the single-sided dynamic balance datetime as a default value. We directly click to confirm. Now we have reached the first step. Interface for initial vibration measurement. We turn on the simulator. Then click F4 to start collecting. The speed has not reached a stable speed yet. We can wait a moment. Now after the speed stabilizes, we look at the anisotropy of the imbalance, angle and amplitude. Wait, after stabilization, we can click to stop collection. It's now at 183 degrees. It's basically stabilized. We can click to stop collecting. Then proceed directly to the next step. This rotor weighs about 5 kilos. The counterweight radius is 80 millimeters. So we enter this information. One click to calculate. The recommended weight is 0.65 grams. Now we found a small inner angle screw of 0.77 grams. We add in. Enter 0.77 into the weighted size. Generally, the default is that the weighted position is 0 degrees. We don't have to type. We can also say that we input an arbitrary angle. It is recommended not to enter the default. Then we directly click Next. Enter the interface of weight measurement.